Welcome. This video goes over Git at a high level. We won't see any commands, but more a discussion about what happens with source control within Git. So to start out, for a lot of us older devs, we lived through a time where our source control, in air quotes, or our backout option for restoring files was just making a copy of a file and possibly adding the date to the end of it. This maybe was in conjunction with Microsoft Visual SourceSafe, which would often get corrupted and not actually provide any value. So even Microsoft has moved on to Git, and it actually is the parent company of GitHub. So back in the day when we made a change, we'd often make a copy of a file as a backup. So if we had a file.c and we wanted to make changes, we'd often make a file2.c or file c.bak or file.date timestamp and hopefully not need to go back. Then along came Git, developed by Linus Torvalds, the creator of the Linux kernel. The Linux code base is contributed to by thousands of developers around the world. Obviously, Git is a tool that can scale and be used by many people across a large geographical area. Linux kernel devs were further along than the file.back devs. They were using another tool called BitKeeper at the time before Git. Linus has spoken about this origin story before, so if you're interested in finding out how he came about developing Git, Google is your friend. So a historical record, that's what Git does in general. Git organizes a historical record. It's a snapshot of versions across time. This enables a user to snap back in time if they need to. The Git repository, or what we'll refer to as a repo, is what holds this information. So let's look at centralized versus distributed source control. So in a centralized system, such as Subversion, here there's a mastered code base, which is stored on one central server. Users can branch and work directly against that version of the code on that remote server. Each developer connects to it and makes changes to the items on that server. This is a single point of failure. Distributed version control, such as Git and also another item called Mercurial, have a master branch, but the entire code base is stored on all devices that have access to it. Users can branch and work against a version, committing changes to a local version of the code, and then determine if they want to share that. So in this instance, say at the very beginning of a project, we are starting with a single developer and the code base. Git enables other users to make a copy of the entire code base and keep it locally. This can go on for an infinite number of times in developers. So what this means is that all devs have a complete copy of the code base to work from on their local environment. In reality, we often designate one of these nodes as the final source of truth. For existing projects, this is a place we will usually start out from, but the point is Git can act in this mesh-like way, and there's no need for a single point of failure. Let's step back and flesh out some of the vocabulary words I've been using, like repository, commit. So a repository is an index tracker of changes made within a project. The repo contains an index and a database. This database is a direct acyclic graph. That's a data structure for all you computer science graph theory type people. The repo keeps track of the objects stored in the database. A commit represents a snapshot of the repository's currently staged changes. It's a logical milestone in the evolution of a project. It should be a single logical change for a snapshot. We should avoid commits that include a logical and in the message when we're describing what our commit contains. It's a snapshot of all files' state at that point in time. A commit contains metadata, and such as a date time, an author, and the message describing what the commit holds. On a side note, Git uses pointers to file versions, not new copies of files when making a commit. Git states. In Git, there are 3 important areas that our work goes as it transitions into being recorded in a repository. There's a working directory, where files in our project folder reside. A staging area. These are things to be included in our next commit of our snapshot. And then the repository, where stuff is safely stored away. So let's walk through a scenario like we're in Jurassic Park. Our working directory. This is the place you work on your files. It's the live action area. We're making changes to things, and it's always in flux. So in our Jurassic Park type of thinking, this is where we're doing our rescue mission. We're making all the changes and gathering people to rescue. We then load all of these people into our staging area. These are the items we want to save. We can do this multiple times until we have what we need. The staging area, as the name implies, is where you're readying items for commit. These items have a logical relation to each other, such as in our rescue, we're going to save women and children first. So we gather all of them first into the staging area for rescue. Once we've gotten everything ready for storage or loaded into our helicopter, we can send it to the repository for indexing. Once the commit reaches the repository, the commit is recorded and stored in the index. We now have a snapshot in time, and the files are safely stored away. Great job. You made it through this Jurassic Park. Let's talk about branching. At its simplest terms, a branch is just a pointer to a specific commit. Branching allows for workflows to make changes, test them out, and then move them forward or throw them away. We're able to create a branch for a specific commit and start exploring changes from there. If we don't like it, we can throw it away and we don't have to worry about undoing or keeping track of all the things that we changed. Git can set the files back to their snapshot in time that were previously stored. If we like what we have, then we can merge into another branch, perhaps going from dev to QA to production. We can kind of think of Git commits as a linked list. Commits are nodes that point to their parents. There's even a special node that can traverse called head. This is where new commits are inserted. For non-data structure people, computer science, we can also think of this like a subway station. As we ride along the train, we're creating new stations or stops. And at each station, we can create a new one on a new line. With code, eventually, we do want to get back to a main line of the station, so we'll merge it back. Let's walk through a simple scenario. We start with 3 branches, all pointing to the same commit 0. Remember, a branch is just a pointer to a specific commit. The black arrows on the left show a logical hierarchy of how we think of our branches. On the dev branch, we make some changes and commit it there. We can then merge that commit to QA so we can test it out, and then finally merge it into master or our production branch. Another reminder that Git is not keeping multiple copies of the files committed, but is just pointing at the versions. All right, great job. Now for a little more advanced scenario. where we have features. So say our team is working on a couple of new features for our product. In this example, we have two new branches in the repository, feature 1 and 2. Everything points to commit 0. In our workflow, logically, we have a production branch named master. QA, we want to test things before production. And dev, where our dev team can do work before handing it off to our testers. In this slide here, there are two new branches for feature 1 and 2. We are basing our start for those features off of the dev branch. So here, we're making a commit in feature 1's branch, and then another team member is making a commit to the feature 2 branch. Okay, so now the feature 2 team is ready to move their work to the development environment after making a second commit. The dev team takes a look at it, says it's good, let's hand it off to QA for testing. So now that the dev branch has been updated, the feature 1 team needs to keep up. Changes made by the feature 1 may be impacted by what feature 2 has already put in. So in order to keep up with these changes, they need to merge dev back down into their feature branch. So feature 1, realizing the changes made by feature 2, maybe have to make another change to go along with that change, or they just have a new change to go along that has nothing to do with it. So now they're ready to share, and they merge their stuff back up to dev. And then to QA, and then on to production. All right, so take a breath. Everything makes sense, right? We didn't use any computer science-y words. And this should reflect a real-world scenario. You're doing great. There's only 2 more slides to go. So GitHub. There are multiple options for hosting Git repositories in the cloud. Bitbucket, GitLab, and GitHub are all examples. These companies offer many extra features on top of being just a remote storage location. Some examples of the features in GitHub include pull requests. This is a workflow method of sending a notice to a repository maintainer that you'd like them to include your changes in their branch. An example in an organization is that a dev can request that their feature branch be merged into dev. Branch security. So within organizations, it's important to have security through separation of duties. We often need to ensure only select roles or users can do things in specific branches. For example, merging changes into QA or production. You can also include code reviews in these workflows. So say it requires another developer to take a look at the code before a pull request can be sent on for consideration. Continuous integration or development. GitHub Actions can automate workflows. These events in the repository can trigger things like automated builds, tests, and deployments. With projects, you can manage a team and create tasks or features, and then track their status through a backlog, work in progress, testing, and done statuses. Issue tracking is available. We can collect feedback from our users, create bug reports, and then we can monitor the fix and see them tracked. You can identify when and what commit that an issue was fixed and moved up through dev, QA, and production. Webhooks offer integration with third-party tools like Microsoft Teams or your own custom application. Last slide. You've made it to the end. Good job, but your journey is just beginning. Git has become a universal tool that just about every developer has in their toolbox. This intro should have provided you with a good why on using Git. Future video will do a how, since I didn't show you any commands or any interfaces for making changes. So on the screen, here's a couple of jumping off points for learning more on your own. Try.github.io and the git-scm.com Both of these are very good options for learning more about how Git works. So good job. You made it through the presentation and learning something new.